homework assignments before we get started? Mm-hmm.
31 on 5.2.
5.22, number 31. Five squared of 2 plus 15 over 7. Yeah. Yeah, you can plug it in. If it's asking you to simplify in radical form, we're looking for non-decimal. If it does work in the calculator, then that's the answer. If it does, it turns it into a decimal, we have to actually solve it by hand. So, all these rational equations with square roots in the denominator, most of those we can do in the calculator. Any other questions on the homework? Coming up soon. All right. We're picking up with where we left off yesterday, which is this problem here. B minus 6 is equal to the square root of 18 minus 3b. First step, is there is there one radical? Yes? If so, get it by itself. Is the radical by itself? Okay. Now that takes us to step 2. We want to put both sides to the nth power. And the nth power in our case is 2. So we're just going to square both sides. Now on the right-hand side, this is a little bit nice because the square root and the square would cancel, telling us 18 minus the square root of 18 minus 3b is 18 minus 3b. Now the other side, we have b minus 6 squared. Well, that's the same as saying b minus 6 times b minus 6. Essentially, that's what we're doing. But when we square it, we do need to make sure we're getting the middle terms too.
So would it not be correct if we put b squared and then just put 36?
Well, so b times b would be b squared, yes? And negative 6 times negative 6 would be plus 36. But we still have b times negative 6, which is negative 6b, and negative 6 times b, which is negative 6b. So we would miss those middle terms. And the main issue is that we have that sign in the middle, the minus sign. If it had just been 6b, we could have squared it and been fine. Because 6b squared, we're used to saying that it is 36b squared, yes? Well, if we do what we just did, that would have been 6b times 6b. Well, 6 times 6 is, it gives us the same thing. But the main reason it does work that way is because there is no sign between 6 and b. So it gives us the same thing. Unfortunately, with b minus 6 squared, we don't just get b squared plus 36. It actually works out to be b squared minus 12b plus 36. So we have to be careful because otherwise we would lose that middle term of negative 12b. Are there any radicals left? No. So we need to get this equation equal to 0. What can we do first? Yeah. We can minus 18 or add 3b first. It doesn't matter which. We just need to pick one. Because whichever one we don't do first, we're going to do it second.
Wait, how does 36 minus 18? Oh, wait, is it not negative 36? No.
Negative 6 times negative 6.
Okay.
And 18 is half of 36. So we can take half of it away. Any other questions on how we got to this point here? We're good with getting to our b squared minus 9b plus 18. Yes? Now at this point we could factor it. We could use the quadratic formula or we can graph it. Which way do we want to do? We graph it.
Can we do the quadratic formula?
Yes. Now instead of b, we're going to use x squared, or x. So we'd have x squared minus 9x plus 18. X squared minus 9x plus 18. And we can say graph. We get this here. We go second graph. We're looking for what values of x will make the y value be 0. Well, that is 3 and 6. So b is equal to 3, and b is equal to 6. Now we will check, but before we do that, we can also solve this with the quadratic formula. Well, in our case, it wouldn't be x, it would be b is equal to negative b squared plus or minus the square root of b squared minus 4ac all over 2a. This b and this b are not the same. Because really, if we're using quadratic formula, we should think of it as this here, and we're really solving for this x. Those two b's are different. Because our b that we plug into the quadratic formula is the number in front of our middle term. So in this case, it'd be negative 9, and that shouldn't be squared. Plus or minus the square root of negative 9 squared minus 4 times a. Well, a is the number in front of x squared, our term being squared, which is in this case is 1. And c is our constant term over 2a. Okay. Now there's a few things we can simplify. The first one's negative 9. It's just 9. 2 times 1 is 2. At this point here, we can plug everything inside the radical into the calculator. So we say negative 9 squared minus 4 times 1 times 18, which is 9. Well, we can take the square root of 9, and the square root of 9 is 3. So we're saying that x is equal to 9 plus or minus 3 over 2. Well, the nice thing with this here is we can actually say, take 9 plus 3 over 2, and we can actually do 9 minus 3 over 2. Well, 9 plus 3 is, and 12 over 2 is, and that's one of the ones we got from graphing, yes? The other one, 9 minus 3 is 6. 6 over 2 is, that's it. Any questions on this here? Now we do need to check 6 and 3. We can check 6 first. So we're going to say 6 minus 6 is equal to the square root of 18 minus 3 times 6. Now the left-hand side of this here is actually a little bit nicer to solve than the right, because 6 minus 6 is 0. 18, square root of 18, square root of 18 minus 3 times 6 is 0. So 0 is equal to 0. This works. So that's one of our solutions. We're also going to check 3. So we have 3 minus 6 is equal to the square root of 18 minus 3 times 3. So on the left-hand side, 3 minus 6 is what? -3, yes? It's not going to work because no matter what the radical gives us, it has to be positive. Because whatever number comes out of the radical has to be positive. It does not work. 18 minus 3 times 3, which actually gives us +3. +3 is not equal to -3. So the one solution that actually does work for this here is that b is equal to 6. Questions on this here? Questions on anything so far? We ready for the next one? Looking at this one here, is there one radical? Well, yes. If so, get it by itself. -4. So you subtract 4 from both sides. Telling us that the square root of 3m plus 10 is equal to m minus 4. Is the radical by itself. So now we need to put both sides to the nth power. And that nth power would be 2. So we'll put both sides to the second power. Now the left-hand side is nice because the square root and square would cancel. Telling us -3m plus 10 is equal to, well, m minus 4 times m minus 4. Because it might be handy to rewrite that out just to make sure we do get all of our terms. So our -3m plus 10 is still -3m plus 10. We'll distribute the m times m is m squared. M times -4 is -4m. -4 times m is -4n. And lastly, -4 times -4 is +16. Yes, we can combine our two -4m's, telling us that we have -3m plus 10 is equal to m squared minus 8m plus 16. Now that we have our terms combined, we need to get this thing equal to 0. So what can we do first? We can move the 3m, but we wouldn't minus it. We would add it. Since the 3m is negative, so -3m plus 3m would be 0, leaving us with 10 is equal to m squared minus 5m plus 16. Questions on this here? And then indeed we would minus 10 from both sides. Telling us that 0 is equal to m squared minus 5m plus 6. We can graph it, we can factor it, we can use the quadratic formula. X squared minus 5x plus 6. And we get two solutions, and our two solutions are 2 and 3. 2 and 3. Any questions on this so far? Now we do need to check these here to make sure they work. Which one of these do we want to check first? 2. So we say 4 plus the square root of negative 3 times 2 plus 10 is equal to 2. Now the right-hand side is nice to simplify because it's just 2. Now we can plug the other side in the calculator. 4 plus second square root negative 3 times 2 plus 10 is 6. So 6 equal to 2? So m is not equal to 2. Let's check the other value. Question? 3 plus 10 is equal to 3. So again, the right-hand side is still just 3. We can do the same thing. 4 plus second square root negative 3 times 3 plus 10 is so this is no solution.
Isn't that the beginning of this problem?
Questions on anything we've done so far? We're ready for the next one. Other way. Negative n plus the square root of 6n plus 19 equals 2. There is indeed one radical, so we need to get it by itself. So we would add in to both sides. Telling us that the square root of 6n plus 19 is equal to
2 plus
n plus 2, 2 plus n. Those would indeed be the same thing. We can have them in any order because that's the nice thing with addition. We can add any two things in any order and get the same value. Is the radical by itself? So now we can put both sides to the nth power, second power in this case. The left-hand side becomes 6n plus 19. Now our n plus 2 squared is the same as n plus 2 times n plus 2. Sometimes it is nice to write it out just so that we have in our mind what we're multiplying by. So 6n plus 19 is equal to n times n is n squared. N times 2 is plus 2n. 2 times n is plus 2n. And 2 times 2 is plus 4. N squared plus 4n plus 4. Questions on how we got to this point here? Now we need to get this equation equal to 0. So what can we do? We can, but it would actually take a lot more steps. Well, not a lot. It's just going to be one more. We can do it because if we subtract 4 from both sides, we get 6n plus equals n squared plus 4n. What would we do next? We would minus 4n from both sides. It would tell us that 2n plus 15 is equal to n squared. And then we would need to subtract n squared from both sides, telling us that we have negative n squared plus 2n plus 15 is equal to 0. Because the way I would have gone about it would have been either subtracting 6n or 19 first. Telling us that we have 19 is equal to n squared minus 2n plus 4. Minusing 19 from both sides. We do get the same solution from both of these. The only reason I do the one on the right is we only had to move 2 things instead of moving 3.
Like that, n squared is negative, so is the negative 2 together. You know what I'm saying?
What values of x make the function equal 0?
Negative 3 and 5.
For which one? Which equation? They're the same. So the solution does not change. Because for both of these, the values of n are both going to be negative 3 and 5. So it doesn't matter which way we do this. I just do the one on the right because we're only having to move 2 things instead of 3. Does that make sense? Yeah. Both work. Both are fine. I just picked the one with less steps normally. But neither one's wrong. So just pick the way that you see. Because once you see one way to do it, go on and do it. Does that make sense? Now, if we had 3 things on both sides, then it's just dealer's choice because you're going to have to move 3 things either way. Does that make sense? All right. Now, we do need to check negative 3 and 5. So, negative 3, we can do it first. And again, when we check, we can type that whole thing in. Negative 3 plus second square root. Already lost. 6, negative 3. 3 plus 19 is 4. So is 4 equal to 2? No, so our negative 3 solution is, now, we can do the same thing with 5. So negative 5 plus square root of 6 times 5 plus 19 is equal to 2. So again, in the calculator, we can say negative 5 plus second square root 6 times 5 plus 19 is 2. Our only solution for this here is n is equal to 5. Questions on this here? We good with this here so far? All right. This one's not in your note sheet, but we're going to go on and look at it. So if you want to get out a blank sheet of paper or something to write it on, you can. We want to solve for x. We have the square root of x plus 2 plus the square root of x plus 1 is equal to 3. So if we think back to our steps, is there one radical? No. Because if so, get it by itself. If not, even them out. Even them out. It is possible to do this without evening them out, but sometimes it makes it easier. So what can we do?
Don't you do the x,
I just need to move one of them to the other side. Doesn't matter which, I'm just going to take this one. And I'm just going to subtract it from both sides, because this one here cancels, telling me the square root of, in green, x plus 2 is equal to 3. Yeah, square root of x plus 2 is equal to 3 minus square root of x plus 1. Questions on this so far? Because we've done one similar to this before, because I believe Friday we had one where both radicals were on the same side. We got them on either side and went from there, yes? But in that case, we had one radical on either side. We did not have the 3. But are the radicals evened out? Put both sides to the nth power. 2, 2. We're going to look at the left side first. Right, because the square root of x plus 2 squared is x plus 2. That's nice. Yes? The other side. Well, this is the same as saying what? 3 minus the square root of x plus 1 times 3 minus the square root of x plus 1, because we're just multiplying it by itself, yes? Left-hand side is still nice. It's still just x plus 2. Here, 3 times 3 is 9. 3 times negative square root of x plus 1 as well. 3 times the square root of, or x plus 1, negative 3 times square root of x plus 1, because they're just multiplied together. It's kind of the same thing as having a variable. We're just multiplying the two terms together. Now, the only way the 3 will go inside the radical is if it's also a radical. If it had been the square root of 3 times the square root of x plus 1, they both had the square root, then we'd multiply what's inside together. Questions on this here? Question? Now we do the same thing. Negative square root of x plus 1 times 3 is, well, negative 3 square root of x plus 1. And lastly, our negative square root of x plus 1 times negative square root of x plus 1. Negative and negative makes a plus, yes? Well, that's the square root of x plus 1 squared, yes? Right. Which we can just say is x plus 1. Now, we could leave it as the square root of x plus 1 squared. And just come down and rewrite x plus 2 is equal to 9 minus 6 square root of x plus 1 plus x plus 1. Because the square root and square do cancel. Negative 3 square root of x plus 1 minus 3 square root of x plus 1. They both have the same radical, yes? We can combine the numbers in front. Because I have negative 3 minus 3, giving us this here. This side's still x plus 2. 9 and 1 are like terms, yes? X is all by himself, but we have x plus 9 and 1 is 10 minus 6 times square root of x plus 1, yes? So that got through step 2, and we kind of simplified down, yes? Well, after step 2, we had step 3, which for all intents and purposes we pretty much ignored. I mentioned it on Friday, and then that's about it. Does anybody remember what step 3 was? Are there any radicals left? Yeah, there is one left, yes? So we go back to the top. Is there one radical? Is there a radical? Yes. Right, so it's pretty much we're just doing it again. So there is one radical, yes?
So it's a square again.
So we get it by itself. So the first thing we want to do is get that radical by itself. Well, now we do have the -6 in front of the radical, yes? That's the last thing we're going to move. What can we move first? X. Well, that's not nice because now we've got variables on the other side. We're going to have these quadratics like we've had today, yes? On the right-hand side, x minus x is 0 like we wanted, yes? How about the left-hand side? It's just 2. Okay, well, that's nice. All the variables outside the radical are now gone. What can we move next? 10. We can minus 10 from both sides, telling us -8 is equal to -6 times the square root of x plus 1. Yes? Now we said a radical cannot equal a negative number, correct? Is the radical by itself? No. To get it by itself, we need to divide both sides by what? -6. Now on the right-hand side, our -6 times the square root of x plus 1 divided by -6 is the square root of x plus 1. -8 divided by -6. -4 over -3, but that's also the same as 4/3. Well, wait a minute. It's not equal to a negative more, is it? Okay, so we're good. Radical, is it by itself? Yes? Now we're going to square both sides. Square root and square cancel, giving me. Now we need to square 4/3. 16/9. It is not, actually. 16/9 is 16/9, because 16/9 is 1.7 repeated. 4/3 is 1.3 repeated. So it is a little bit bigger. Are there any radicals left? No. So we can clear step 3 and go straight to step 4, which is solve for x. And we would so 16/9 minus 1 is 7/9. Question on how we got to this here. Is this much harder than what we've been doing? It's a lot more steps. We just had to go back through it again. Now, if for some reason, once we finish squaring, if there had been another radical, hopefully there wouldn't be, we just go through again and keep doing this till we got rid of all the radicals. 7/9, well, last thing we need to do is to subtract. Well, might as well. I'm going to do this by hand. Because if we're adding these two together to do it, we need the denominators to be the same. Now our 7/9 plus 18/9 would be the square root of 25/9. 7 plus 9 is 16/9. Square root of 25/9, square root of 25 is 5. 9 is 3. 16 would be 4 and 3. And since they do have the same denominator, we can add them, giving us 9/3, which is indeed 3. We didn't have to do that by hand. We could have typed the whole thing into the calculator on the left-hand side, and it would have told us it was 3. So our answer is 7/9. Probably one of the few times that its fraction actually worked and checked out and worked that we were actually okay with. Because it would be kind of pretty upsetting if it worked out that 7/9 did not work. And we did all that work just to find out it's no solution. But that is it. And on the plus side, there's not one like the one we just did on the homework. Because again, I did that so that we could see how that one worked. 45, 46, 49 through 57, odd. Brooklyn, where you put that up? Can you read the instructions for the problem set for that has 45 and 46?
Determine which solution, if any, is an extraneous solution.
Extraneous. So extraneous, are they the ones that work or don't work? Don't work, because the prefix for extraneous is extra, yes? Extra meaning more?
The ones that don't work?
Yeah. They're wanting that you determine which ones don't work, not the ones that do work.
So there's going to be a lot more?
No, it gives you two. It gives you two values. It wants you to tell it which ones don't work, not the ones that do work.